Hi class, in this lecture we want to move into section 2.4, and this is talking about using derivatives to find absolute maximum and minimum values. So in previous sections we've talked about relative max and relative min. So this one is this is going to be talking about the absolute maximum value or absolute minimum value for a function over a specific interval. Okay, so suppose we'll start with the definition of what exactly is an absolute minimum and an absolute maximum. So suppose that f is a function with domain I. Okay, so the domain is some interval. F of c, so the value f of c, so just so we're clear, that's the y value, right, of the function, is an absolute minimum if f of c is less than or equal to f of x for all x in this interval I. Okay, so it's the lowest possible value. And the same the flip is true for the absolute max. So f of c is an absolute max if f of c is greater than or equal to f of x for all x and I. So this is the max value. Okay. Note, just a quick note, absolute maximum minimum can occur at more than one point. And you'll see that in an example what I mean by it, occur at more than one point. Okay. So for one theorem, to start here, we have what's called the extreme value theorem. So a continuous function f defined over some closed interval a to b must have an absolute maximum value and absolute minimum value on a to b. So what that means is suppose you have this function, okay? And we're going to look on the interval a to b. If it's continuous from a to b, there's no way to draw it so that it doesn't have, remember, it has to be continuous, that's important, so that it doesn't have a minimum value and a maximum value. You might say, well, what if it's just a straight line, right? Even that has a maximum and minimum value. So let's just say this is the value 5. So this actually has a maximum, absolute maximum value of 5 and an absolute minimum value of 5, even if it's just a horizontal line here. That's okay. So as long as it's continuous, and this is important on the closed interval, so including the endpoints, all right, it has to have both a max and a minimum value. All right, so let's talk about finding ways to find this absolute max and min. So this is the maximum minimum principle one. So suppose f is a continuous function defined over the closed interval a to b. Okay, to find the absolute maximum minimum value on ab, you have to do the following things. First, you find the first derivative, okay? And then you determine all critical values, that is, find all c in your interval a to b for which the first derivative, when you plug c in, is equal to 0. The first derivative doesn't exist. So remember, what the critical values are telling us is these turning points, these valleys and these peaks occur at critical values. So we're going to find them, okay? And there could be more than one. Okay, so we're going to denote the critical values as C1, critical value 1, C2, C3, so on and so on, okay? Next thing you're going to do is you're going to list all the values that you just found, all those critical values, and the endpoints. Okay, so you're going to list all your critical values. And remember, A and B, what A and B are is they're the endpoints, okay, of the interval, because we said it was defined on this closed interval from A to B. Next, all you're going to do is you're going to evaluate f of x for each value in that you listed in the step above. And the largest of those is the absolute max of the function over that interval, and the smallest of those is the absolute minimum value of f over those intervals. All right, let's do an example so you can see this. All right, so I want to find the absolute max and minimum values of this function. F of x is equal to x cubed minus 3x plus 2 over this interval. I just picked this interval from -2 to 3/2. Okay, so the first thing you're going to have to do is you're going to have to find the first derivative. Well, that's really easy, right? The 3 comes down. This is 3x squared minus 3. and the derivative of that is 0. So you're going to look next, you're going to find critical values. So it's a polynomial function, so you're just looking where this first derivative is equal to 0. Well, you'd add 3 over, you divide by 3, so you get 1, and then you see that x is equal to plus or minus 1. So look, you have two critical values, okay? And both those critical values fall in this interval here. So the next thing you're going to do is you're going to list these values. Okay, you're going to list starting with the endpoint -2, then we have the value -1, then we have the other critical value +1, and then we have 3/2. Okay, so look what we've done, just going back. We found the first derivative, we found critical values, okay? And now we've listed the critical values with the endpoints. Okay, so now what we have to do is each of these 4 values that we just found, we have to plug into the function. Okay, so our function was, again, f of x is equal to x cubed minus 3x plus 2. So look, you're going to take these values here and plug them in. So you're going to plug in f of -2, f of -1, f of 1, and then f of 3/2. Okay. Now I'm just going to save some time for this, and I'll leave this for you to evaluate. But when you plug in -2, you end up getting 0. You end up getting 4. You end up getting 0. And then when you plug in 3/2, you end up getting 7/8. All right. So look, let's start with the absolute min. So the absolute min value, if you look here, the lowest value here is 0, okay? And it occurs twice. So the absolute min value of f of x on this interval -2 to 3/2 is 0. It's the value 0, which occurs at 2 points, right? It occurs at -2, 0, and it occurs at the other point 1, 0. So this is what I mean by your absolute min value can occur more than once. And look, let's find your absolute max. So the absolute max value of this function f of x on this interval, so on this closed interval, okay, is the value 4, which occurs at the point -1, 4. All right, so we got a good start to seeing like how we just find the absolute max and the absolute min values on a closed interval. All right, so let's do a second principle of this, okay? Now suppose f is a function such that f prime exists, okay, for every x in some interval I, and there exists exactly one. So there's only one critical value. So notice that this principle is not going to work for the previous example, because if you look at the previous example, right, we had 2 critical values. So here there's exactly one critical value, okay, and that critical value is one for which f prime of c is equal to 0. It does not exist. Okay, important. Then f of c is an absolute maximum value over I if the second derivative evaluated at c is less than 0, or f of c is an absolute minimum value over this interval I if f double prime of c is greater than 0. So this is just like the second derivative test, okay? And what we're able to say then is, oh, look, if there's only one, it's got to be an absolute max and an absolute min value. All right, so let's try this one. Let's find the absolute maximum and minimum values of this function. All right, so the first thing you're going to do is you're going to find the first derivative. Okay, and if you take the first derivative here, you end up getting 4 minus 2x. Okay. Now, the next thing you're going to do is find critical values. Well, you're just going to look where the first derivative is equal to 0. Well, you're going to add the 2x over, so you get 2x is equal to 4. and you get x is equal to 2. Notice, this is incredibly important, only one critical value. Now, and my apologies for not making this clear, but notice how there's no interval given. I'm just saying find the maximum minimum values. So when no interval is given, it's just asking across the entire domain. And so the domain here is literally negative infinity to infinity. It's all real numbers. Okay, so I've got one critical value here. All right, so looking back here, look, there's exactly one critical value. Okay, so then I want to say if this value here, this f of c, when I take this critical value I found and plug it into the function, is an absolute max or min. Okay, and look, first off, what is f of 2 then? Because that's our critical value. If you take 2 and plug it in the function, you get 4 times 2 minus 2 squared, which gets you 8 minus 4, which gets you 4. Well, now let's use the second derivative. So if you find the second derivative of this, right? Like what is the second derivative here? Well, that's 0. This is just minus 2. So look, if you take f prime of your critical value, f double prime of your critical value, it's still negative 2, which is less than 0. So what do we have? We have an absolute max. So thus the function f of x, which is this 4x minus x squared, has an absolute max value of 4, which occurs at the point 2 comma 4. Notice, because we're looking over the entire domain, there is no absolute minimum value. And that's because if you look at the graph of this, right? Like the graph of this is a parabola opening downward, so it just decreases without bound forever. So there cannot be an absolute min because it goes down and down and down to negative infinity. All right, let's just do one last quick example here. Let's find the absolute maximum and minimum values of the function f of x is equal to 5x plus 35 over x over the interval from 0 to positive infinity. Okay, so my interval goes from 0 to infinity. All right, so to do this, again, you're going to have to find the first derivative. So if you find the first derivative of this function, you get 5 minus 35 over x squared. All right, and since f prime of x exists for all x from 0 to infinity because it's an open interval here, the only critical values are those for which f prime of x is equal to 0. So you just need to look where that happens. So to solve this, you set it equal to 0. Let's add this over. Next, we're going to cross multiply, right? Divide by 5. And the reason here, when you get x squared is equal to 7, I'm only listing one solution. It's the square root of 7. Again, that's because, going back, I'm asking you to look over the interval from 0 to infinity. So just positive. Okay, so just positive values. Okay, so the interval 0 to infinity is not closed, and the only critical value is the square root of 7. So again, there's only one critical value. Okay, so thus we can use that maximum minimum principle too, using the second derivative. So look, if you were to find the second derivative of this function, you would get 70 over x to the third. So if you plug in the square root of 7 here, look, it's just a positive number. Okay, I'm not even going to figure out what it is. It's just a positive number. Okay, because you're only interested in the sign. So what that means is f of x has an absolute minimum, right? Because when you plug in the value at the second derivative, the critical value of the second derivative, if it's positive, it means it's a minimum. So you just have to figure out what that value is. And if you plug in the square root of 7 into the function, it simplifies to 10 square roots of 7. Okay, I'll leave the algebra for you. So thus we have an absolute minimum of the function f of x is 10 square roots of 10, which occurs at x is equal to the square root of 7. All right, class. So I hope this helped to learn how to find absolute maximum minimum values. And if you have any questions, as always, let me know.